Hey everybody, super excited for this chat today with the CEO and co-founder of Sentient. We're going to talk AI and machine learning at the edge. Kurt, how are you?
I'm really good and very happy to be here.
Well, I'm happy to have you. This is a very hot topic, as you are no doubt aware. And you've been at this for some time, moving intelligence to the edge. Maybe introduce yourself and a little bit about the backstory of Sentient and how you guys got started.
Yeah, sure. Let's see. I've been in the semiconductor business for, gosh, must be 33 years now, and have done most roles from design and engineer to CEO of a public company. And I got together with my co-founders in late, let's see, I guess it was late 2016, and we actually started working on Sentient in early 2017 with this idea that the world needed a new kind of processor. We had seen that there was huge advances going on in machine learning basically happening in the cloud, and that was largely brought about by the massive processing power that GPUs brought to the table. And we saw that there was, let's call it 20 billion plus MCUs or small processors, MCUs, MPUs used in devices, and none of those could natively do machine learning. And we saw this tremendous opportunity of let's take machine learning processing that in those days was something that only happened in the cloud. Let's build a new kind of processor and build and put it into the devices. And today we see those devices installed in things as small as earbuds to as large as automobiles.
Well, that's quite an ambitious goal, given the tech giants that are in this space. We'll dive into that. But so talk about your platform. You have a neural decision processor that's making some waves here. Explain, how that's different from a CPU or a GPU that we hear about all the time for kind of today's AI
Yeah, that's
applications.
a great question. Generally, if we see how AI came about, is you really needed three things. First, you needed massive processing power. The second, you needed some kind of platform to run on it. And the third, you needed a bunch of data. And all these kind of things happened in sort of 2015, 2016, and so on, where we had GPUs, we had platforms like TensorFlow, and we had this advent of big data. So we said, okay, what could we do in the edge? And in the edge is a little bit different than the data center, primarily because it's very constrained. Is that you have price constraints because it's in a device people buy, you have power constraints because it's often ran on batteries, and you have size constraints. So we said, how could we build a new kind of processor that addresses those sorts of things? So we built an architecture that we call at-memory compute. And the idea here is that the performance and the power bottlenecks of machine learning are all about moving things around in memory. So we said, if we could build an architecture that limits or absolutely eliminates the movements of things that would go basically moving in and out of memory, we basically could have something. And then we said, okay, if we take that out memory compute and then we make it natively aware of neural processing. So neural processing has a limited number of operands or atomic units, if you will. It has things like fully connected layers. It has recurrent layers. It has convolutional layers. It has attention and activations and things like that. So let's build those in hardware and operate on them super, super efficiently. These are all things that a traditional compute can't do. And then, so we came out with our first chips, and we compared those to other devices. And one of the I'd say interesting examples is very early on. We said the first machine learning application at the edge is going to be a wake word. So we did the Amazon Alexa wake word, and we did it at 140 microwatts. And this was about 100 times lower power than the next lowest power device. So we
Wow.
realized we had something. We said, okay, this is, we're doing the same amount of performance at 100x lower power than a traditional processor. And then we looked at, let's expand the wake word. Let's expand the workload. Let's go from wake words to let's do image. And we ran a similar benchmark using MobileNet, which is used for image, and we had that same 100x dividend. And so when you ask the difference between a traditional processor used at the edge and a processor that Sentient would offer, is that if you're doing the exact same workload, say you have a battery life of 3.5 days, with a traditional processor, an ARM or something like that, do that same workload on a Sentient processor. Instead of 3.5 days, you get a year. And that's really the difference that we're bringing to the table.
Wow, that's pretty impressive. Talk about a 10x, maybe 100x advantage.
100x, 100x
Not so
dividend.
sure. That's amazing. So, with all the applications out there, what most excites you? I mean, you're in, the automotive space. You could be in smart home. You kind of just mentioned healthcare, wearables. Are there some sweet spots that you really see your advantage coming to the fore?
Yeah, there truly are. When we look at it, what is machine learning good for? I mean, this is the question I always get. It's like the cocktail party questions, like, what is it good for? And I look at it as that machine learning is good at operating in very noisy environments, taking a lot of data and making it something useful. Okay, let's step back for a little bit. And we see that, what are these sorts of things? It's very good at moving the real world to the digital world. And if I look at, where is machine learning used for today? We do event detection like glass break and gunshots. We do voice wake words, command words. We can do artificial vision. This is generally, we would call this interface. And this is what machine learning at the edge is good at. It's good at interfacing the real world to the digital world. And if I look at my history of interface, today, I'm talking to you on a laptop and it has a keyboard. And the keyboard was our first interface to computers. And that, I mean, it seems kind of quaint now, but with MS-DOS, it shipped at about 150 million units a year. And then we had the mouse. And the mouse opened up a whole new world. And with Windows and other GUIs, those devices ship at about 500 million units a year. And then we had the touch screen, and the touch screen brought across the smartphone. And we'll call this 1.5 billion. I think the next generation interface is going to be around machine learning. And that machine learning interface will be at its very basic levels, event detection like glass break, wake words, command words, and then ultimately conversational speech. So you asked me what I'm most excited about. I'm excited about interfacing edge AI with this advent of large language models. We're seeing absolutely amazing work being done with large language models in the cloud, but today it's kind of clunky. You type something and you wait a few seconds and it has to go, it has to go up there, come back, and so on. What we really want to see is full conversational interface to a device. So instead of trying to figure out, what is the right temperature to cook my potatoes or something in my oven, I could just tell the oven, I'm cooking potatoes, turn it on. Or, or maybe just, I need to change the clock. It's changed from regular time to daylight savings time. I mean, it took me so long on the devices this weekend. So I think that's the future. It is really this interface to large language models. And the first step of that will be to move the text to speech and speech to text into the device. And that can reduce your latency by about 50%. And then the next step is to take those large language models and stick them into the device. And I think we're almost there. And, these won't be huge, they won't be monstrous ones like ChatGPT-4, but they might be useful ones. And they might be useful to do a lot of things that I could basically do with my device. So that gets rid of any kind of learning curve. You just hand a device to someone and they talk to it just like they would talk to you and immediately get to being productive.
That's fantastic. Well, as someone who tries to talk to my Apple Watch all day on Siri, I can see some of the limitations, that latency issue, and Siri isn't exactly an LLM as we have noticed. So
Exactly.
yeah, Apple's gonna have to figure out how to bring their tech to the next level. Sounds like you're on an interesting track. And you touched on energy efficiency and power, sustainability. I mean, is the current arc we're on with AI sustainable for the long term? Because it seems to be sucking every watt of power out of every data center we're going to possibly put into production. I mean, something's got to give, right?
Yeah,
If
something
AI becomes everywhere.
certainly has to give at some point. But I mean, where there's a will, there's a way. And
Yeah,
as long as the economic value of the AI, and let's assume the societal value is equal or exceeding the economic value, I think people will continue to invest and build these data centers. But they're always looking for lower power ways of doing things. And a lot of this, if you move it into the edge, you actually get a much lower power solution. And today, we see examples where if everything goes back to the data center, you're not only consuming the power to do the processing, you're consuming all the power for the transport. And that power for the transport of that data to and from the device is considerable. So as long as we can start moving things more and more into the low power edge, we can actually drop the overall power consumption and the overall carbon footprint of that operation. It's much more efficient if all I'm doing is talking to my phone, as opposed to talking to my phone that's going to the base station, that's going to some central office, that's going to a data center, and back, and so on.
Fantastic approach. So, talk about your go-to-market. I mean, you're an early stage company surrounded by tech giants, titans from, the Qualcomms and Intels of the world, and, who's who out there on the semiconductor side. What is your go-to-market? How do you work with strategic partners or
Sure.
tech partners? How do you collaborate to get your technology to market?
Yeah. So we have a couple of tenets within Sentient, and the first one is that no one wants to buy from a startup. So I talk about it at every all hands, basically a couple times a week, or not a couple times a week, a couple times a month at our all hands meetings. As I say, okay, no one wants to buy from a startup, and if you want to supply something to a big company, and they have the option of buying something close, almost as good from a big player, they're going to buy something from a big player.
Mm.
And so there's two ways around this. And one is to offer something that's truly exceptional. And I learned early in my career, one of our board members, I presented them this new product idea. And I said, okay, here's this new product. It's going to be awesome because it's 10% better in these 15 different parameters. Maybe it's 20% better in a few of them. And the board member looked at me in the eye, and he just said very, very, very easily, he goes, that product will fail. He goes, no one cares that you're 10 to 20% better in a whole bunch of parameters. What you need to be is 100%, or you need to be 10 times better in one parameter that people care about.
Wow.
And I really took that to heart. And I said, that's right. I need to be truly exceptional in one parameter that people care about. So when we looked at Sentient, we said, what are we good at? We're good at high performance at ultra low power. So let's build something that's at least 10x better than anything else out there. And it turns out we built something that's about 100x better. But that is a way to go to market, that we can go head to head with people, that when there is a power constraint, they'll go with Sentient. And this has been super, super effective for us. And then taking that one step further is, as I said, there's kind of two ways to go about going up against the big guys, is go somewhere they're not. And we drew a box around our market as always on battery powered. And as long as you think about always on battery powered, it does limit your market, but it's actually pretty big. Is on the smallest, it's an earbud or a hearing aid that's always on. But on the large side, it could be an automobile. And people say, well, an automobile has this great big battery, why do you care? Well, what if you want to do a always on security system in a car that must last for a month in an airport parking lot on the 12-volt battery? Wow. In that case, you really care about battery or power consumption. So the space for us is really big. So we take those two tenets. One, let's go somewhere they're not. And two, let's offer something that's 100 times better than what they're offering.
Wow, what a fantastic approach. Talk about where you are in your rollout, your deployment, any success stories you could talk about, OEMs, design-ins yet, or are you sampling products out there?
We're in production now with 2 generations of hardware and software.
Oh, okay.
We've shipped, today in the field, there's about 50 million devices that have Sentient technology in them, whether it's hardware or software. And those are in always on machine learning applications. So they're being used, dozens, if not hundreds or thousands of times every day. So this is a pretty good amount of deployment. Our 3rd generation is in the fab, and it is designed really to address edge conversational speech. So we're really moving there. We've gone from keyboards to mice to touch screens to conversational speech, and that's right around the corner.
So I think you set out about what 7 or 8 years ago with this vision, this mission. Is that right?
Yeah,
Uh,
I guess it's 6. It feels like 20,
6. Okay.
but yeah. So we actually we started.
That's
I started working on this January of 2017, but we got our first funding in October of 17, and it was quite an adventure. We told our friends we're starting a chip company, and they said, "Yeah, that's really funny. No one's done that in like 30 years." I think the Theros was the last one the last successful chip company that was started. He said, "You really should try software. That's where the money is." And it turns out, part of it they were right. An AI chip company is largely a software company. Probably 70% of my engineering team are software engineers.
indeed. Yeah. So I presume the LLM phenomenon has really lit a fire under your business, and the opportunities have just grown exponentially. But that's just my hunch. What say you?
Yeah, it's really great. I mean,
Mm.
I've been showing the same technology progression slide for 5 years now, and ending in conversational speech. And now the technology is there. I say, okay, it's caught up. Here we are. This is what we're going to do. And it really boils down to kind of how we got the first idea for Sentient is, we were looking for a killer app. You always need to have what's your killer app. And at the time, my son was talking to his iPad, and I said, what are you doing? And he goes, I'm texting my friends. And I'm like, well, you can barely, you can't type, and you can barely read. What are you doing? He goes, oh, I just talked to it. And at that point, I called my co-founders, the next day, and I said, this is what we're going to do. We're going to use AI to talk to things. And it's really worked out splendidly. And now with the advent of LLMs, it's so much better than just a wake word and a personal assistant. And we're seeing that the big personal assistant vendors are coming out and saying, we're going to supercharge our personal assistants with LLMs. So that'll be really an amazing experience for anyone. They'll just be able to talk to their device, whether it's something in the cloud or whether it's something inside the product.
Yeah, I can't wait for that humane pin that's sort of a smartphone on your chest, like a Star Trek communicator that just lives there, and
Absolutely.
you can get rid of your device altogether. Stuff like
Your
that is just
digital
so
buddy.
awesome. And describe behind the scenes a little bit about the culture and the environment that you've helped foster. I assume you guys are all together on the
Yeah,
design side.
we're not as together as I'd like.
Uh-huh.
So, I think every CEO says this, but so, we started in Irvine, and that's, most of the team here is in Irvine. We have a good technology base in Orange County, and it's, much better it's a great place to start a company. Turnovers is low. The, great education system, lots of big companies to hire from. Then we have a big team in Silicon Valley as well. In Mountain
Mm.
View, and that's worked out very well. We have Sentient North and Sentient South. And then we have a team of people really all over the world to support our customers. We support people in Europe and India and China. Generally, the customers are in all over the spots. So, and then a few people remote here and there, but generally we're back to the office, which I think is a much better application. We talk about culture, and I'm proud to say that we've won the best place to work in Orange County 4 years in a row.
Wow.
And
Wonderful.
I think a good part of that is culture. One of my good friends always reminds me that culture eats strategy, and it's important to remember that. And I really look at these three things. Is one is we only do things that are exceptional, because if you don't, no one's going to buy it from you. The second idea is this idea of respect. And, this was, we came up with this tenet before COVID, but it actually really worked out very well. And during the COVID times, is that when we're all on lockdown, there was a lot of I'd say, frayed tempers. You're sitting, 3 or 4 people are working in a
Hmm.
small house or small apartment, all work, you're all like on top of each other,
Hmm.
conflict with your roommates or your spouses or whatnot. So, the reminder of respect, I think, was really important at that point. And then the third tenet is really around gratitude, is that it's, I believe that no person is an island, and we all do this we all work together to actually get somewhere. And this has been a big deal at Sentient because AI is doing something new. Is you need to have silicon, you need to have data, you need to have models, and you need to take people that are from very diverse backgrounds. We interleave. We don't have a software team and a hardware team. We interleave the hardware and the software people together. They all speak English, but God, when we first started, they did not communicate among themselves. It was pretty dang funny.
Engineers, can't get them to talk. But yes,
Yeah, I
yes.
was sitting in the middle of it, and I'm going, okay, I'm listening to these guys talk, and they are not talking to each other. They're speaking English, but they don't understand it at all. But I think that's how we've achieved these kind of performance levels, is that our hardware guys and our software guys are very, very intertwined, and improvements we make in one can affect improvements in the other.
Well, it's a wonderful mission, wonderful vision you have, and so excited to watch it. What are you looking forward to as we close out the year, the quarter? Any events or travel or other things on the radar?
Well, we're gearing up for CES. It's always a
As
great
am
show
I,
for us.
so hopefully I'll see you there.
Yeah, please
Fantastic
come
event.
by. I'm looking to break my record of meetings. Last year I did 110 meetings in like 4 days. So we'll
Wow,
see if
that
we
is
see if we
that
can
is
do
fantastic.
that. I'm just getting my voice back now in November, so it was it's always a trying week, but yeah, we're definitely looking forward to that. I think it's going to be a great event.
Fantastic. Well, so thank you so much for taking the time to share your insights and the story with the viewers here. And thanks everyone for watching. Reach out to Sentient with any questions, comments, and look them up at CES for sure. Thanks, Kurt.
Thank you, Evan. It's really enjoyed talking with you.
Likewise. Take care, everyone.